I want to thank very much the organizers who believed that my work was relevant enough to be presented here, although I'm not yet a researcher, and for your work for the advancement of women in research. So this is the final thesis for the International Master in Quaternary and Prehistory, and was developed under the advising of Professor Maria Soto and Professor Carlo Lullier. This research is focused on the Western Mediterranean, in specific on the islands of Corsica and Sardinia. The aim was to reconstruct the possible routes taken by humans for procuring lithic raw materials during the early peopling of these islands, that is from the Pre-Neolithic up to the early Neolithic. The two main topics that we wanted to investigate were both the mobility of these human groups and their procurement strategies. And the perspective was diachronical, that is, we wanted to address possible changes and differences through time. Why did we focus on lithics? Because lithic tools are the archaeological remain available, often the only one, at sites as ancient as these chronologies on these islands. In specific, we chose obsidian and chert as proxies for this research, as obsidian can be especially understood as a mobility marker, since its origin is restricted to very few localized sources, while chert instead is more ubiquitous, more common, and could thus provide information also on preferential selection and management of resources. Now, a bit of contextual data. There are very few available paleoenvironmental data for these chronologies in the islands, and the timing of the first settling of humans is also debated. Occasional settling has occurred from the 9th millennium BCE onwards, while the early Neolithic covers the whole 6th millennium BCE. Mesolithic and Neolithic groups have been two different populations. And from the point of view of subsistence, Mesolithic people relied on the hunting of small game with traps, on fishing and gathering, whereas Neolithic people practiced herding together with hunting-gathering. To answer the research questions, we developed several research objectives to collect other important contextual data, namely the location of settlements and the circulation of lithic raw materials. Thus, we first built a database through bibliographic research, recording all known archaeological sites to date and their lithic assemblages. As a result, only 11 pre-Neolithic and 38 early Neolithic out of the total archaeological sites have yielded obsidian or chert. As we wanted to create a cartography depicting the geographical distribution of these raw materials, we used the software QGIS 3.20 to build a map, and then georeferenced both the archaeological sites and the raw material sources. As regards the location of the sources, all of them are located in Sardinia and no outcrop exists in Corsica. In the case of obsidian, only one source area exists, corresponding to the Mount Archi, as you can see here, in the central western region. This is also one of the only 4 obsidian sources located to date in the entire Western Mediterranean. So we obtained 2 maps, one for the Pre-Neolithic. We have to note that all sites must have been at a significantly higher distance from the coastline. And as the sea level has been rising steadily, it is also very likely that several sites are lost because they are currently underwater. And we obtain another map for the early Neolithic. As you can see, the sites increase significantly with the Neolithic. Georeferencing the sites means locating where chert and obsidian were brought by humans to produce stone tools, while georeferencing the sources means locating where they have been procured. So we have the beginning and the end of a movement, several movements across the territory. In order to trace the paths of these movements, we assumed humans would have had to follow the easiest routes across the territory, that is, those with the least energetic cost. There are several specific functions in QGIS to calculate the least cost paths, which take into account given variables. But for this research, we chose land slope as the only variable, as there were no complete data, for example, on hydrology, vegetation, climate, even potential sea routes were excluded for the same reason, and we just traced them as the crow flies according to land into visibility. Based on the least cost paths, these are the conclusions we obtained for Sapinian Corsican Mesolithic groups. During the Mesolithic, humans mostly settled in subcoastal areas, but had started to explore inland territories. Lithics were probably obtained through embedded strategies, that is, occasional access to the sources during other subsistence activities of the foraging type. As you can see from the thematic maps, these are absolute numbers, not percentages. The presence of chert and obsidian is rather poor, thus their use was very occasional in this period. We do not even have data for obsidian provenance. In Corsica, both chert and obsidian items are so few that their presence is likely the result of an epiphenomenon of sporadic nature. Some chert has been traced back to the Perfogas Basin in northern Sardinia, which shows that round trips towards Sardinia did occur, but occasionally, which also points to a relatively higher mobility than previously assumed for these groups. Instead, in Sardinia, chert is likely the result of a strictly local exploitation in the vicinity of the settlement. The conclusions for the early Neolithic are very different. The herding, hunting, gathering economy is compatible with a still highly mobile lifestyle, which is reflected by the circulation of lithics. The presence of chert and obsidian rises significantly, thus we have an intensive exploitation of the sources. The procurement of the lithotypes at high distance from the source probably took place as indirect procurement or down the line informal exchange, while direct access from distant sources is unlikely because of the large distances involved. From Corsica, in fact, to procure obsidian directly from Mount Archi, one should have had to face a minimum journey of 370 kilometers and a maximum of 577. And there is also to consider the crossing of the Bonifacio Strait. The same, of course, applies for chert. Long journeys are also the case for procuring obsidian in Sardinia from distant settlements. Instead, direct procurement was likely from neighboring settlements. This is the case for procuring obsidian from near settlements in Sardinia or for the supply of chert. In fact, while Corsican chert is alloctonous, most of Sardinian archaeological chert is of strictly local origin. Finally, one important thing to highlight in both long and short distances is that the provisioning of obsidian was generalist, as you can see from the even circulation of all geochemical groups of obsidian. Namely, there is still no control exercised by local communities over the obsidian sources of Mount Archi. As a conclusion, some limitations and problems. First of all, this research was carried out on data from mostly poorly studied archaeological sites, which frequently have unreliable stratigraphy or dating, whose lithic assemblages are rarely, if ever, fully analyzed. Furthermore, although least cost path analyses are a tool for studying the relationship between humans and environment that is becoming increasingly popular in archaeological research, it is also widely debated. Its main problem is, in fact, its very premise that humans act efficiently, which is not always true. As Bradley et al. Have stated, landscape is permeated by meanings. It is not a simple source of provisions. So it is clear that humans, while moving in the landscape, their movements cannot be understood as a mere calculation of energy cost. Nevertheless, it is mostly impossible to reconstruct the system of meanings of past humans, while energy cost is a variable among others that are usually considered by humans as they move through a territory. And as opposed to variables concerning habits, behavior, and symbolism, it can be studied. This research is thus to be understood as a premise for future developments in a context where this type of analysis had not yet been implemented. Thank you very much for your attention.
So, hi everyone, I'm Clara and I'm going to talk about carnivores, humans, and their interaction during the Upper Paleolithic from the Olivo cave. But first of all, I want to congratulate all the organizers. Thank you for let us share our work here. Carnivores are usually present on archaeological sites as scavengers of the remains left by the humans, but there are some sites where we can see the alternation in the occupation between the humans and carnivores, especially during the Middle Paleolithic. This tendency tends to decrease in the Upper Paleolithic because of the increase of the human intensity, but we can still see this alternation in some sites. El Olivo is an archaeological site in Llanera, Asturias, in the north of Spain. It's a karstic cave with a short development, almost 12 meters, and it has been excavated between 2012 and 2017. 7 layers have been distinguished in this site, and the level 2B is dated on the Middle Magdalenian. And apart of the found remains, we have found some ornaments, bone, and lithic industry. The sample is composed by 2,848 remains from the different levels, and more than 7% of the sample has been identified anatomically and taxonomically. And the remains that only be identified, the anatomical part, has been grouped in 3 size groups: in small size, medium size, and big size animals. And among them, the medium size and the small size animals are the most common ones. So in this side, we can see the anthropic action by the presence of the good marks resulting directly from activities like skinning, evisceration, deflation, and disarticulation. And also we have seen some percussion marks related with the marrow consumption. There is a high fracturation of the fresh bones. 80% of the sample is less than 5 centimeters, and almost 85% of the fragments of diaphysis are under the 25% of the total circumference of the long bones, and 87% of these remains are also less than 25% of the total length of the bone. Also, there are some remains that have been exposed to the fire. The good marks has been observed in levels 1, 2, 3, 4, and 7 in all sizes, including rabbits and bears, but especially in the medium and small size animals. And normally they are concentrated in the appendicular and axial elements. On the other hand, the carnivore activity can be observed in levels 1, 2, 3, 4, and 7 in animals from all the size groups, including rabbits, birds, and small carnivores like Lopis lagopus and Vulpes vulpes. The carnivore activity is concentrated in the appendicular and axial elements, and the ratio between the number of tooth marks per bone suggests a moderate carnivore activity. We can recognize who made the accumulation, because when the humans approach the animals, we will find a specific distribution of the good mark percentage, especially on the upper part of the limb bones. We will also see percussion marks and a high degree of fragmentation because they break the bones to access to the marrow. And on the other hand, the carnivore accumulations, we will have another specific but similar distribution of tooth marks. Also, in the upper part of the limb bones will be more abundant because humans and carnivores want to access to the most part of the meat. Probably there will be an astrological bias in the skeletal profiles and a lower degree of fragmentation. So for the interpretation of the origin of the accumulation of El Olivo, we part from the works of Domingo de Rodrigo and Barba, and we quantify the marks by element with special interest in the humerus and femur and by bone section. The quantification has been made on a number of remains. We take in account the foot marks, percussion marks, and tooth marks. And the frequencies have been calculated only on these bones with bone surface conservation. So according to this model, when the humans access first to the animal and then the carnivores, we will find a high percentage of foot marks in the upper part of the limb bones and a high percentage of tooth marks in the lower part of the appendicular skeleton. And we will find the inverse model when the carnivores access first to the carcasses. Applying these methods to El Olivo, we can find that levels 1 and 7 show high frequencies of tooth marks and a really low percentage of tooth marks. So this is consistent with the model left by the humans when they access first to the animal. Levels 2 and 4 show a really low anthropic action and high percentage of carnivore actions. So this is consistent with the carnivores as main contributors of these carcasses. And in level 3, we can see an intermediate situation because the anthropic and carnivore action is quite similar, but the study of the tooth marks shows that in addition to the fleshing, the humans carried out some evisceration processes, and these normally are related with a primary access to the carcasses because the viscera are really nutritive. For the medium-sized animals, levels 1, 2, 3, and 7 are consistent with the pattern left by the humans when they access first to the carcasses, and the level 4 show a pattern left by the carnivores. However, we can see here a contrast between the frequency of tooth marks and the presence of foot marks left by different processes of the butchery. So this suggests that the medium-sized animals could be contributed also by humans, making this level as a palimpsest. For the big-sized animals, they are similar to the framework reference in all levels. There are no anthropic evidence, only in the level 3, and specifically in the lower appendicular skeleton. So now, trying to identify who was the author of the accumulation, we have remains of some carnivores in El Olivo. We have remains of hyenas, wolves, fox, felids, and ursus. And when we compare the behavior with the data from El Olivo, we can see some matches. But the hyena are really destructive. We don't found coprolites, the pivot tooth, or cylinders. So we propose the wolves and fox as main accumulators of the assemblages. And the fox and hyenas, especially as secondary agents scavenging the remains. So in conclusion, the small animals were accumulated by the humans in levels 1 and 7 and contributed by the carnivores in levels 2 and 3. And in this last level, there is a shared axis between both agents. Medium-sized animals were mainly contributed by the humans in levels 1, 2, 3, and 7, while the large animals were contributed by carnivores in levels 1, 2, 4, and 7. And in level 3, we can see again a shared axis between carnivores and humans. Level 4 is mainly accumulated by carnivores apporting animals from all side groups, but the humans also contribute with medium-sized animals. Levels 5 and 6 have not enough data to make a diagnosis about the accumulation, and we propose the Canis lupus probably as the main agent of the accumulation for these animals, and then vulpes, Canis lupus, and sometimes the hyenas act to a secondary agents scavenging the remains left by the humans when they are not in the cavity. So these are the references, and thank you very much for your attention.
Thank you for allowing me to present the result of the technological analysis of the Knapping system in the area D of Jaljulia, Central Israel. This is part of my current postdoctoral fellowship here in Tel Aviv University. And this subject will allow us to talk a little bit about the continuities and the discontinuities within the lower to middle Paleolithic transition in the Levant. So first of all, some words about the context. We can see a combination of changes in the hominin behaviors during the lower to middle Paleolithic transition in Eurasia, Africa, and in the Levant. These changes are the common use of fire and the common use and the mastering of fire, but also new subsistence strategies such as small game hunting, among a lot of others. Within the lithic technical system, we see, generally speaking, the progressive disappearance of bifacial shaping technologies and the emergence of new flaking methods, mainly with the VCWAP technology, as you can see on the right of the screen. The aim of the VCWAP technology is to produce predetermined flakes with important cutting edges. Until today, there are still major issues about the first manifestation of this technology worldwide. In the Levant, we have three main lithic technocomplexes dealing with the lower to middle Paleolithic transition, contrary to the European archaeological record. The first is the late lower Paleolithic with the late Acheulean, dated between 8 and 400,000 years ago. The second technocomplex is really specific from this area of the Levant. It is the Asturias-Yabrudian with its particular facets, such as the Hamudian and the Yabrudian. This facet is dated between 420 and 200,000 years ago. And the last lithic technocomplex involved in this transition is the early Middle Paleolithic, dated between 250 and 150,000 years ago. As you can see, there is an overlap of these lithic technocomplexes, chronologically speaking. Here we will present data about the site of Jaljulia, which falls into the late lower Paleolithic. The site of Jaljulia is located in central Israel near other famous lower Paleolithic sites, such as Eyal in the north and Kisem Cave in the south. It was recently excavated by Mayan Shemer and Ran Barkai between 2016 and 2017. 7 areas were uncovered during the excavation, and they are all attributed to the late Acheulean. Jaljulia is more a complex of sites with different occupations around the Wadi Kana riverbed. The occupations are on the top of gravels and ambra soils that are typical geological formations of this area of central Israel. Most of the time, a single archaeological level was uncovered. Only one area, the area G, as you can see here, shows a multi-stratification of the archaeological level. There are almost no faunal remains in the site because of the bad preservation rate. Our technological study was made under area D, which is the oldest one that you can see here. This area was the deepest level of occupation of the site and yielded 1,000 lithic remains. The archaeological level is of 30 centimeters thick, was excavated on 16 square meters and corresponds more likely to a palimpsest of lower Paleolithic occupation. This is the only area with faunal remains, even if there are really few, and they were attributed maybe to both primogenies. This area was dated around 500,000 years ago by a combination of CTOSL and ESR dating. The raw material employed in Jaljulia are almost exclusively from the local area, directly within the alluvium of the Wadi Kana near the site. And as you can see on the map, the Wadi Kana crossed numerous flint formations on the north here, a lot of different flint formations. It's only flint that was used in the site, mainly the brecciated campaniate flint from the Mishash formation that you can see here on the screen, and that presents important linear variation in quality. The lithic analysis of the material shows the presence of different components. First, the flake production systems are really dominant. Within this flaking system, we identify specific hierarchical production corresponding to type of Levallois and Levallois. Cordon flake are also present, really typical from the lower Paleolithic there. And also some discoid-like production, like you can see on the scan. There is also an important component of bifacial technology in this area of Jaljulia, and this technology is currently under the of my colleague Sol Sanchez de Tagalan, who is another postdoc here in Tel Aviv University. There are also a lot of tools on flakes. They are diversified, not truly standardized, and we have like skyscraper, notches, and denticulates. We can also underlie the presence of artifacts with double patina that suppose the recycling of previous collected items and corroborate the balances of occupation in this level. The particular subject of this talk is this specific hierarchical flaking method that were identified here in Jaljulia. We divide them into two categories, the typo Levallois and the Levallois classic flaking. The typo Levallois does not fit all the criteria defined by Eric Boeda for the Levallois definition, but fall within the same volumetric conception here. Both Levallois and typo Levallois were applied on small pebbles and cobbles, and sometimes also on flakes, as in the center of the screen. The main difference between these two methods are sometimes minimal preparation of the striking platform here in the case of the typo Levallois, and the exploitation of natural blank morphology for the convexities. So this is a lesser degree of preparation. These, broadly speaking, Levallois flaking are mostly recurrent unipolar and dipolar, leading sometimes to elongated products, as you can see on the right of the screen. The core convexities management is made by debordant and backed flake, which is typical for recurrent Levallois systems. And the objective of production here are linear cutting edges opposed to a back of flakes, or flakes with peripheral cutting edges, which are also really classic of recurrent Levallois systems. In the Levant, hierarchical production are often noticed during the late Acheulean, but only in small proportions. In Gesher-Benotiakov, for example, we have only few cores that exhibit such volumetric conception, but they are made from recycled items of bifacial technology. Most of the time, the cores don't fit all the Boeda's criterion and can be considered only as typo Levallois. Levallois production are then absent totally during the Acheulean period, and their presence is only found with the early Middle Paleolithic. The production of the lithic technocomplex are very different from those from the Acheulean, and more similar to those of the classic Middle Paleolithic, with the first systematic Levallois point production, for example, here in Mislia cave. So we can thus wonder about the place of Jaljulia reduction processes and this first Levallois technology within this context. To sum up, we have in Jaljulia a specific level of production with both core and related products. This production is independent and not made from recycled items, as it was often the case during the late lower Paleolithic. And moreover, here we have the proportion of this production, which is important, leading to an unusual technological association during the late Acheulean. Related to lithic technocomplexes in the Levant, Jaljulia shows different technological patterns that led to an invention of specific level of production during the late Acheulean. But if we compare with the Acheulean in the Levant, there is no persistence of such technologies. Levallois technologies appear again around 200,000 years ago during the Middle Paleolithic, but with really different forms and sometimes with clear laminar production. Thus, we can see a local development of hierarchical and sometimes Levallois technologies during the late Acheulean in the Levant, but technological legacy is lost during the Acheulean phase. On the other hand, we see a clear break with the early Middle Paleolithic, which stands with a new arrival of population, maybe from Africa. But if the early Middle Paleolithic is associated with Homo sapiens remains in Mislia cave, for example, in Israel, we can see technological differences that are existing in comparison to the early Middle Stone Age from Africa. This is why we need more data to consider all the hypotheses about these issues and the population movement dynamics within this key area, which is the Levant. So thank you for your attention.